All right, next I want to talk about geospatial technologies. And we've touched on this a little bit. We briefly talked about maps and GIS, but I want to expand that discussion a little further and talk about more of this family of what we call geospatial technologies. And what it is it's bringing the map information, the tools of the traditional tools of geography, and leveraging the digital environment. Technologies like web-based mapping, remote sensing, getting information from satellites, visualization techniques like with Google Earth, GPS, and really at its center is geographic information systems, or GIS. So I want to talk a little bit more in depth on GIS in particular, remote sensing, but just bear in mind that these are kind of a collection of what we call geospatial technologies. So just to back up a bit, we talked about the elements of basics of geography, that geography is the science. One way to call it is a science of where. It is the spatial science of where things are. And we geographers study spatial relationships of people and things on Earth. So it's really all about location, location, location. And we talked about how we describe absolute location using latitude and longitude. And again, latitude and longitude is a mathematical way of describing any location on the Earth. Latitude is your position from the equator to the poles, and it's a system of angles. So here at the equator, it's 0 degrees, and if you kind of go up this angle, the North Pole is at a 90-degree angle, so it's 90 degrees. Halfway would be 15 degrees. Longitude is measuring around the Earth. And if you spin around once, you make a 360-degree turn. And likewise, there's 360 degrees of longitude around the Earth. And when we measure, we divide it in half, 180 degrees east, 180 degrees west. And so just to, look at latitude and longitude in practice, the city of Merced, we're in Fresno, but I had a canned example using where I used to teach in Merced. We could describe it as being 37.29 degrees north latitude and 120.54 degrees west longitude. And so this is an old map that has the latitude and longitude in the corner. And it's using a different kind of a notation. It's using degrees and minutes is kind of a different way of describing it. 37 degrees and a quarter and 120 degrees and a half. This is a screenshot from Google Maps of the area around Merced, California. And you can see here too, it's a different way of describing it. It's using, if you're using Google Maps, you may see these numbers on the screen that move or that change as you move around on the screen. But what it's doing is that the URL is actually, part of that is your latitude and longitude in the middle of your screen. And so this way, if I copy and paste that link and I send it to somebody, they will end up in the same, looking at the same location because the link included the latitude and longitude. So we use latitude and longitude every day, but it's kind of behind the scenes in Google Maps, navigation, and anything that has what we call location services. Your apps knowing where you're at, that's using latitude and longitude. Now, how would your phone know where you're at? And the way that your phone or other devices know where you are at is by using satellite technology. And there's a big term we use to describe all of it, GNSS, Global Navigation Satellite System. But really, this is GPS. And the reason why we don't just call it GPS is that there are other systems around the world that are like GPS that work in similar ways. Some from other countries, Russians, European Union have some of their own systems. But the big one, and the one that we use, is GPS. GPS is the original system, and so, but it's not now the only system, but it is the primary navigation satellite system. Now, the way they work is that wherever you're at, these satellites are constantly sending out a signal, and the time, and with a timestamp, and it notes the time that it takes for the signal to get to you. And that's the key thing, that one of the key elements about GPS is accurate clocks. So the satellites have highly accurate clocks on board. When they're sending out these radio signals, they're encoded with the time. When you get it in your phone, you could just hold up my phone, I guess, but your phone knows what time it is and knows how long it took for the satellite to get signal to get to your phone, because the difference is in the time. So highly accurate clocks are really what make the system work. I'm going to include a video that really kind of shows that in depth. So for your tractor here or your phone or what have you, you're receiving signals from more than one satellite. For each satellite, your receiver knows the distance using the differences in time. And by doing that, using geometry, you can calculate where your position is based on your distances from those known located satellites. Satellites know where they are. They transmit that location where they are, and they transmit the time, and a bunch of math goes on, and you can calculate your latitude and longitude. Now, maps do also have some severe limitations. Traditional maps are created by hand. Your measurements have to be done by hand, and there are hard, because it's a physical piece of material, there's limits on what you can visualize at one time. People had different ways of, creating sort of see-through overlays that they would lay on top of maps, but it gets messy. There's a really hard limit to what you can do. So that's why geographic information systems is so important. And what they do is they bring themes or layers of information into a digital environment. Now, these layers can be updated digitally, and your computer can do all the measurements. So no more hand measurements. The computer can do these for you. So for example, if you wanted to calculate the area of the feature, rather than having to hand measure that, the computer can do that for you. And because you're in a digital environment, there isn't a limit on how many layers of information. And so what that does is allow you to answer much more complicated questions, because you can have a lot more information at your disposal to work with and to analyze. Now, one thing I want to clarify is that these layers are not pictures of maps. These are what we call abstracted features that are on the maps. And I'll talk about what that means in a moment, but you can have layers of land cover, structures, counties, and different things. And when I say abstracted features, so rather than being a picture of a map, what people have done is converted the map information into geometric features. So for example, it can be lines, points, and polygons. And in this example, the housing lots are polygons, the enclosed areas, the streets are lines, and the maybe fire hydrants are represented by points. That's one way to do it. There's two different ways of doing this that you can use. That's called the vector method. This is where you have geometric objects like polygons and lines and points. And a second way, so here's the real world. We want to put that real world, we want to abstract that and put it into the computer. We can represent it in two ways. One is as polygons, lines, and points. A second way, a different kind of way, is using a raster. And these are grids of cells. So what you do is you take this area, you split it up into a grid. It's kind of like a digital photo, and these are all pixels, except that the pixels have numbers that represent, whether in this example, some have numbers representing grassland, some have numbers representing a marsh, and so on. And so, you would choose one of these ways depending on the type of thing you're studying and the analysis you wanted. Now, the second part of this is the information systems part. So this is a picture of a GIS, and these are some polygon features representing vegetation categories. And you see some are highlighted here. Now, behind the scenes, there's also a database, kind of looks like a spreadsheet. It has information on the, whatever information you want to store, like you would in a database. And here I've selected some things on the map, and likewise, those are also selected in my database. So you have the map interface, but behind the scenes, you're also working with a database. So these abstracted features like polygons also have associated database records, and these databases can be very complicated. Like this is, for example, is one on soils for the United States. You can have names, size, classification. It can be as complex as you need or want it to be. And so the combination of having all these multiple layers and attaching these features to a database let you do a lot more complicated work than you could with traditional map sources. Some of the things you can do, for example, you can combine layers and create new ones. If you want to look at, soil and elevation and some other features, you can put them together and come up with a new map that has features from different ones. And you can also really use the database. You can leverage the database information to answer very complicated questions.